Synchronized Genesis sequence. 5, 4, 3, 2, 1. Enjoy.
All right, they said to enjoy, so probably should enjoy. Thank you for joining for this very important session that we'll try to figure out what DevOps for developers is and if it's even for developers or maybe against them. I'll start with the conspiracy theory. Are you ready? It's going to blow your mind. So we'll try to keep it here in like grounded to reality, but who knows? Well, I have a proof though. So hear me out. DevOps is a conspiracy by ops people to make us, the developers, work harder. Who agrees? Well, not enough, because I do have a proof. Okay, I'm going to prove it to you, and then you will all have to agree that this is true. My name is Baruch Sadogurski. I'm J Baruch on socials, and I'm a developer productivity advocate, hence the t-shirt, with the company called Gradle. And my personal path is I started as a developer many years ago and then spent quite a lot of time doing DevOps-ish things with the company called JFrog that you might have heard about. And now I'm working on developer productivity engineering in another great company called Gradle that you might have heard about. Wrote a couple of books. This particular one is very relevant to our talk. This is my creds that I know what I'm talking about. DevOps tools for Java developers. This is exactly what we're going to talk about. Why we need DevOps tools. Do we even want DevOps tools for Java developers and what's not, and the liquid software. And that's a book about how we're going to release our software in the future. A little bit of that is already here. So yeah, the most important slide of this talk is this one, show notes. If you go to speaking.jbaruch, and thank you Swiss people for the domain, the slides are already there. The video I'm recording right now, and it's been recorded by the organizers, so redundancy, yay. All the links for everything that I'm going to mention, all the books, all the resources, everything is in there. And to make it easier for you to remember, it's conveniently in the bottom of every slide, together with the hashtags Devoxx and DPE for Developer Productivity Engineering, and JBaruch on to praise this talk on socials. You can do it right now, even before it started. Give me some credit. That's going to be awesome, because it will. So, as I mentioned, developer many years ago, and you know how it works, once a developer, always a developer. So I know exactly what I'm talking about when I'm telling you that DevOps is a plot of ops people to make us, the developers, work harder. Exhibit 1, the Phoenix Project. Who read this book? Not enough of you. You are in luck, whoever who did it or who didn't, because that's the book that you need to read to understand DevOps completely. And it's not boring, it's actually a novel about a certain engineer who invented DevOps and managed to turn his failing company around and win using DevOps. How awesome it is. Very fun to read, highly recommend it. You know where to find it, the link to it right here. So yeah, to understand what this book is about, all we need to do is to look at the cover. The cover has all the main characters in the book. I'm going to go through all of them one by one to make a point. So here on top we have Patty. She's the director of IT service support. And this is Wes, and he is director of distributed technology ops. Well, Sarah, she's in marketing, and then Steve, he's the CEO. Dick, he's the CFO. This is Bill Palmer. Bill Palmer, he is the protagonist of the story. He is the one who invents DevOps and wins, and he is VP of IT Ops. We have Eric, who is the board member. He kind of feeds the ideas to build, to invent DevOps. He read another book that it's called The Goal by Eliyahu Goldratt. And this book is a novel about a different theory called the theory of constraints that DevOps is actually based upon. So it's kind of a meta, very fun. Brent is a lead sysadmin. He is the hardcore engineer in the story, and he is obviously a sysadmin. And then there is John hiding in the back there because he's security. People hide from other developers. What do you notice? The book is full of ops people who invent a great methodology and then actually win using this methodology. There are some developers in the story, and between you and I, they're not pictured in the best light. There are the people who kind of drop their keyboard at 5 p.m. and go home and leave the shit that they coded to the heroic ops people to overcome and deploy to production. Exhibit number 2. Who teaches us what DevOps is? If you Google what is DevOps, you will find some very profound results from companies like Amazon, which is an ops platform, or Atlassian, the DevOps company, or GitLab, the CI/CD DevOps in the box, whatever their line is, Microsoft, another ops platform. Who else we have here? TechTarget, they're journalists, Wikipedia, obviously, Synopsys, they do DevOps tools, and then Logs.io, observability, DevOps tools, and then IBM, they also try to have a DevOps platform. Well, this is interesting. Right? I mean, this is very clearly something that ops people really try to push. And the interesting question is why? Why a bunch of ops people decided that they need DevOps, that they need to invent DevOps, and then that they need to actually teach us DevOps? So here is another something that I found. Quora, questionable, but okay. Someone asked, as a Linux administrator, how do I shift my career to DevOps? And then DevOps online trainer for 10 years actually give their advice, which is, well, you already know Linux fundamentals, you're almost there. All you need to do is learn some cloud, something that is called Gits, and Maven for some reason, and then you're good. So basically, you are a sysadmin, ops person, learn cloud and Gits, and you're golden, you're DevOps. And next thing you know, this person goes from making this a year to making this a year, which is kind of nice. And then the next thing you know is there are 20,000 open positions for DevOps engineers, regardless of all the layoffs and what's not, and people making money on certificates for DevOps engineers. So there is a lot of money involved, which is kind of interesting, but it's not really the reason, because no one knew it's going to be that huge. If you ask Patrick Dubois, if you ask people who really kind of came up with the idea and ask them, did you ever thought that it's going to be that huge? No one thought it's going to be that huge. So money cannot be the reason, and we need to ask, once again, why? And as you know, if you ask why enough times, you will be promoted to an engineering manager. We'll stop at 2. So here's another reason. This is what we call DevOps infinity loop. It looks very familiar. Anyone? This rings a bell? Yeah, what it looks like? What does it remind you of?
Waterfall model.
Well, the opposite of waterfall model. Actually, it looks exactly like the agile circle, right? So those are the iterations. This is your agile sprint in which you go to plan, code, build, and test, which absolutely makes sense. We do it on a daily basis. This is our life as developers. Now, for some reason, the ops people decided that they will take this and they will attach their own thing to it, which is release, deploy, operate, and monitor, and say, okay, this is your job now. More proof. State of DevOps report. This is a very, very important document in the DevOps world. I would say the most important. And this is kind of a study of, or research of where the industry now in terms of adopting DevOps. Now, this is from an old one, but I think it's very interesting. The new work here is in bold and highlighted for a very good reason. We want to spend our time doing new work because this is where the money is, and also, frankly, this is where the most interesting challenges are. And then there is everything else like unplanned work and rework, stuff like bugs probably, security issues, defects, customer support. This is all great. But this new work, one wonders, what does it mean for people who created the DevOps report? And we can read through the methodology and we can see what they mean by that. And they mean by that stuff like planned work, business projects, or new features. Well, this is great. But then internal projects, server migrations, software updates. Well, changes driven by feedback on completed work, this is fine, but also unplanned work, support escalations and emergency outages. I mean, this is all very fascinating, obviously, but it has very little to do with the work of developers. What is the work of developers? Well, new work is writing code, and then refactoring is writing code, and then fixing bug is writing code. No outages or software updates or escalations. So all the DevOps things is ops people trying to make us, the developers, work harder. Who agrees with me right now? I want to see the number rise. Well, actually less. How is it possible? Doesn't make any sense. Okay, I'll pretend that all of you raised your hand because I had proof. And I will ask you another question. Let's say DevOps is really not our job. Let's say, well, we are not doing any server updates or emergency outages. What is our job as developers? How do we define our job? There are obviously many definitions. The one that I really respect is the Manifesto of Software Craftsmanship. There are a lot of questions for the authors and how things are praised, and even the term craftsmanship is problematic, but I think the essence of it is very, very solid. When you look at the items, stuff like not only writing software, but well-crafted software. Do we care about quality? Hell, we are. Right? Not only responding to change, but driving value. Do we want to understand what our customer want and be proactive? Sure. Not only individuals, but community of professionals, of course, and not only customer collaboration, but productive partnerships. This is all makes a lot of sense to me. I hope it makes a lot of sense to you. But if we want to break it down to a list, look at it and come with a list of software definition of done. What it means for us, the developers, done software. I would go and say something like, we understood what the requirements are. We write clean code that doesn't have a lot of bugs. We write code that is easy to deploy, right? Getting back to this picture of developers from the Phoenix project that made code very hard to deploy and then the ops people suffered. We don't want that. We obviously want code that is easier to deploy. And then we met all the non-functional requirements, performance, throughput, security, and then we didn't accrue new technical debt. Maybe we fought an old one, great. Tests are passing to the level that our QA is happy with the quality of our code, and then team lead is happy with our velocity and what's not, and product owner, who is the proxy to the customer, is also happy, right? I mean, Make sense? Pretty much. I already mentioned that we care about the quality of our product. And many years ago, I saw this illustration that I was really annoyed with. It says like developer and tester has this animosity, right? They are like hiding a knife behind their backs. Who thinks it's the case? No one? No one. A couple of hands. Yeah. So I completely agree. It's not the case. It absolutely doesn't make any sense because we do care about quality, right? We want to write quality software, and QA people and testers, they're there to help us writing quality software. Not only finding bugs, but also teaching us how to write tests, how to test our software. They are our friends because we take pride in the quality of our software. Sorry for the Soviet meme. Sometimes it kind of just runs away from me. So anyway, what is quality? Quality is a fluent concept. It's a fluent concept because it changes. Let's go back in time. Let's go back to 2007, the first time I looked at the website of my bank. And this is what it looks like. So obviously very naive design. The thing is, the most important part is it didn't do much, right? I could probably check my balance and well, that's pretty much all. And if I wanted to do something meaningful, I just walked to the branch. There are like news and announcements and sometimes something like that, like 12 hours maintenance for website quality appeared there. Did I mind? I really didn't because it didn't do anything anyway. So 12 hours update window was completely okay with me. Is it okay with me now? Of course not. Our standards of quality changed over time. I personally switched the bank over usability of their app. This is how important IT quality became to us, and this obviously puts more requirements of what we perceive as quality. And the problem is that it's not only code. Data affects how our applications behave. And the more data we have, the harder it is to test our software. Seagate predicted 2018, that's the last time they did this, that the annual size of the global data sphere will reach 175 zettabytes next year. What is zettabytes? What is big data for us today? What units? Petabytes. Petabytes is like big data. So like your Googles and Amazons and Microsofts, they operate in petabytes. What comes after petabytes? Exabytes. Zettabytes is the one after. This is a lot of data, like a lot. And what it means that even when we distribute the majority of it to your Googles and Microsofts and Amazons, more and more companies have so much data that testing our application with the relevant amount of data pre-production becomes unfeasible. And that means that this nice tool that let us test something before we dump it on unsuspected users is now gone. More and more companies give up on the staging server because it doesn't make any sense now. We cannot, you remember the promise of staging server. It's the same environment as our production, but we can test of it without any users that will actually suffer. Now, if it has significantly less data, it's not representative anymore. And if we try to put as much data as needed on it, it's just too expensive. So either you just don't have it, or you have a server which is not on par with production, and this means not a real staging server. So what do we do? What do we do? We obviously test in production, right? There is an entire industry of testing in production, and there are like a lot of buzzwords around it, stuff like progressive delivery, stuff like canary deployments, feature flags, and what's not, controlled rollout, it's kind of the big name. Now, the most telling term here, and the one that I like the most, is blast radius. What it essentially means is that when we deploy the production, there will be casualties. People will suffer. We will, for sure, guaranteed, going to deploy code that has bugs and not of a perfect quality. And the only thing we can do is try to minimize the number of people suffering using this entire thing. So what does it mean for us? Recalling that we are developers who care about quality, and now we understand that the real quality that matters is what is deployed to production. What it means for us is that we have to be there when when our code is deployed. It means that we need to be there on call. Now, yes, no one wants to be on call at 3 a.m., but it's your code that's making a mess. No one else can be there except of you. And you don't have any way to prevent this mess from blowing up at 3 a.m. in production, as we just spoke. So, what it means that we need to fix our code in production is that our code needs to be DevOps ready. Our code needs to be able to perform in the way that those pesky ops people expect it to behave, because it's 3 a.m., blast radius, there are casualties, people are suffering, and we need to fix our shit. Sorry, we need to monitor our product in production. What does it mean to be DevOps ready? This is a term that is very, very tightly coupled with what it's called cloud native, because cloud native was born as a solution for this kind of challenge. So what can we know? What should we do? First of all, it should be absolutely clear how our software is deployed. It cannot be like, yes, we have a pipeline, but also there is one person in the company that knows a secret value for a secret environment variable that they need to go and update after the code is in production. Right? That cannot happen. Stable and fast build. We have a bug, we need to fix it, and then we need to build our software and deploy it. And it should happen very, very fast. Stateless is a nice request because it provides our usability to scalable, very, very simple. And then fast startup and fast stop. This is critical because now we need to replace a version in production, and for that we need to shut down and then bring new one online as fast as possible. Observability, discovering that our code doesn't work from people's complaint on Twitter is probably not the best strategy. Preferably we know about it beforehand, and we do it with observability. Feature flags, you know what's better than fast replacing something fast in production? Just turning it off with one flag. That's what feature flags allow us as well. Backwards and forwards compatible. Backwards compatible, of course. Now we replaced a module, and new modules should be, and old modules should be able to talk with the new modules, and new modules should be able to talk with the old ones. So obviously, it's very, very important. Event streaming as a part of observability and everything else, right? So, in the end of the day, now we as developers are in charge of doing something that serves and helps DevOps and the ops people. So, regardless whether we like it or not, this is part of the game. The problem is, it's been more than 10 years. It's been like 15 years now of trying, and developers are still not excited about DevOps. They're still not excited about those requirements, still not excited about being on call at 3 a.m., still not excited of what they perceive as more work out of nowhere. And usually this is how it works. This is how people are kind of shoved into, hey, you need to do DevOps, but obviously that's not how we want to operate. What we want actually is to go from this to this. Funny story. There are no, well, at least I couldn't find a single GIF in the internet that goes from sad to happy. It says something very profound about our society. I have no idea what, but I had to reverse the video to make it happen. What is DevOps? 15 years ago, we had a very stupid Venn diagram that looks like this. No one understood what it means. It made no sense. Something between DevOps and QA. Is it like some people that's supposed to be all of that? That was very strange. Then we progressed to think about DevOps in light of something between people, how they work, and what tools they use. And over time, we got to realization that it's all about productivity. Productive people using productive process and using productive tools to release software in better quality, faster. Now that makes sense, and now we can work with that and implement those pieces. So, productive process, we nailed it. What it's called Empower Teams, it's the teams that have representatives from Dev, Ops, QA, Product, Security. Everybody work together, understand the requirements, implement the pipelines, and then work together. Productive tools, well, kinda, sorta, more or less, we figured that one out as well. What about productive people? How do we make people on those productive teams as productive as possible? The pain is real. So Gradle, we do developer productivity and build tools. Obviously, we do survey that one of the questions is, what is slowing you down? And 90% of IT organizations said that slow build and slow tests are slowing them down. That's not surprising, and it's widespread. I guess you all feel it in that way or another. It's not only that, there are others. Stuff like inability to easily troubleshoot and determine the root cause of build, test, and CI failures, 65%. Or insufficient observability of analytics on build and test performance and the regressions in this performance, failure traits, productivity bottlenecks, almost 60%. There is a lot of suffering when it comes to developer productivity. And once we figured out what DevOps is, why do we need it, and how do we participate in it, stuff like observability on our production systems and progressive delivery, our next frontier is the production systems of our production systems. And that's our development environments. So what we need here is something that will help us as engineers, all of them, Ops, Dev, QA, be more productive. And one of the answers is noise cancelling headphones. The other part of this equation is developer productivity engineering. Developer productivity engineering is an engineering discipline that is built on tenets like eliminate toil for developers, right? So when you need to do something that is there and it's not making you more productive, this is toil and should go away. AI helps us a lot in exactly that, right? So if you need to write documents about the next feature that you are going to do, probably you don't write documents anymore. You write prompts for the documents. And if you still, you shouldn't. But this is kind of example of eliminating toil for developers. Collaborate through effective tooling. Here I also have an example of a failed build. So let's say your build is now failing and you expect that your colleague is to blame. What do? You reach them on Slack, they were doing something, so you interrupt them, and then you dump on them your build log. How productive is that? So there are better ways, and if you can send them a link to the line of code that broke the build, that would be much more productive. So that's collaborative through effective tooling. Prioritize automation, eliminate bottlenecks. This is DevOps tenet. This is actually theory of constraint tenet from the goal that was the kind of inception of the Phoenix project, which was the DevOps and all that. So it's from there. If you optimize in anywhere else except of the bottleneck, you don't optimize at all. So finding the bottlenecks and then optimizing them through automation is the key, not only for optimizing manufacturing process, back to the goal, or ops processes, back to Phoenix project. It is actually also true for your developer environment. Rigorous observability for proactive improvement. What does that mean? We have observability. We solved observability out. There are tons of companies that do and excel in observability, your Datadogs and Splunks and Logs.io and who's not. But what do they observe? 100% of these companies observe one thing, your production environment. Is it a bad thing? Of course not. You'd better observe your production environment. But we can do more. We can do the next step into your developer environment and observe it as well. Organizational mindset. This is something that we managed to get for DevOps. And ask any company now, any manager now in any company, they will tell you, yes, we think about DevOps day and night. Do they think about developer productivity? Nah, I bet they don't. And if they do, they don't think about it enough. Outcomes over output. Remember the failed build? The entire log is the build output. The line why this build is failed is the build outcome. We really need more outcomes and less output. The last one that I want to talk a little bit more about, which is, I would say, one of the most important one, is foster faster feedback. Fostering faster feedback is absolutely critical for us to be more productive. So, wait a second, I have some problem here with the slides. Oh my God. Here we go. Feedback efficiency. What is feedback? We write our code in our IDE of choice, which is obviously JetBrains IDE, or maybe not, but yes, it is. Sub-seconds feedback efficiency, right? We type our code and it immediately marks if we typed something wrong. Build. We expect the build to finish fast and get feedback in seconds, ideally. CI will take longer, and then feedback for production. Remember, we are waiting for feedback in production because that's the really feedback that matters for our quality, will take even longer. If we plot it on a diagram, we'll see how the more left we shift toward the developer, the faster feedback we expect. Now, this is the expected feedback efficiency, but there is an exception. And this painful exception is build. Unfortunately, our build is much slower than we need it to be. Thinking about build in terms of it has tests and it gives us as much feedback as possible. Whose build here is less than 1 minute? Couple of hands. How about less than 3 minutes? More, I would say, what, 15%? How about less than 5 minutes? That's less people. I don't know how it's possible, because if you have build that is less than 3 minutes, it's obviously less than 5. Okay, never mind. I'll stop asking questions. It doesn't work. So yeah, our build is painfully slower than we want it to be. And the problem with slow build is that it is a very specific type of feedback. There are two types of feedback, asynchronous and synchronous. And asynchronous build is stuff like your CI. Now, your CI can be slow, and it's definitely slower than whatever your local build, 5 minutes, 10 minutes. It can take half an hour and what's not, and it's absolutely fine. It's fine because you don't wait for it, right? It will take whatever it will take, and it's very annoying when it breaks. But you don't wait for it. It runs whatever it runs. Synchronous build, synchronous feedback, like build, you want to wait for it because it's part of your synchronous routine. You want to wait for it in the flow, but then obviously when it is slow, it's very annoying. You will start to multitask. You will check your email, you will check your Slack, you will do other stuff. I promise not to ask questions, but I will. How long it will take you to come back to the build to see if it finished or failed? Who thinks less than 5 minutes? Couple of hands. Who thinks less than 10 minutes? Okay, lots of hands. Who thinks it will take 20 minutes? Some hands. All right, so I have bad news for you. Science. Professor Gloria Marx did a lot of work about attention span, and her findings is that on average, the time to get back to the task that we were distracted from is 25 minutes. You know what it means? That whoever raise their hands that this build is slower than 1 minute, I have bad news for you. Your build is 25 minutes. Not funny. Very scary. So yeah, build should be extremely fast. Commit line is where synchronous and asynchronous kind of feedbacks break, because after commit you go and do other stuff. So how can we engineer less context switches? What can we do? First of all, we need to know how long our build is. I asked questions, people answered. If this is your own build, you probably know. If you are a team lead or a manager, do you know how long it takes for your team members to run their build? Maybe yes, but also maybe not. Especially in a remote environment. People working from middle of nowhere, Nebraska, on Starlink if they're lucky, or like just I don't know what kind of internet if they're not. How long their build is? Who knows? Probably no one. Once you realize that you can optimize your build, the next step will be avoiding what didn't change. There are a couple of techniques to do it. The one is baked into your build tool, and that's incremental build. If you have a modular structure of your build tool will skip the modules that didn't change and will only try to test what your modules that you changed affected. The problem is that it's not great. First of all, it relies on architectural decisions that might be all kinds of sorts of, but also it relies on build artifacts to realize what was built and what's not. The better alternative to that is caching. Caching actually works always, and it works without relying on architectural decisions, and it can also work for everybody if you use caches that you built to share it with your colleagues, and they don't need to build it as well. Another avoidance technique before I jump to the next one is predictive test selection. Predictive text selection is a machine learning algorithm that will learn which changes of code trigger which tests to fail. And then over time, it will know how to skip tests that are not expected to fail when you change a certain code. It works surprisingly, or maybe not surprisingly, it works very well and saves a lot of build time. Now, what you cannot skip, you need to speed up. And there are ways to speed up your build dramatically right now, today. First, use the entire power of your local machines. I have an example here on this machine of a build that runs for 2 minutes. I change one line of code in my build, and that is use all the available cores. And the build goes from 2 minutes, 120 seconds, to 10 seconds. 12 time improvement, one line of code, no new hardware, no new techniques, nothing. Just utilizing the entire power of this machine. You know what has more cores than my computer? The cloud. The cloud has infinite number of cores. So if during my local build I can take my tests, send them to the cloud, parallel them through all the cores in the cloud, not all of them, but some of them, and then collect back the data, I can speed up my build even further. Or maybe not, depends on how many tests I have. But sometimes it really speeds things up. So, and it's not CI fan out, because I'm not doing it for CI. I'm doing it for my local build. It's very powerful. Flaky tests, yes, fight them. They are evil and they disrupt your build because tests really should either fail or pass. Both of them are very useful outcomes. Flaky, not passing and not failing is the worst. And obviously, we spoke about observability and degradations, right? So, what you can do today to improve your developer productivity for absolutely free. Parallel local builds. That's what I mentioned. You just instruct your build to use all your cores. Next thing you know, your build is 12 times faster. Your results might vary, but that's the gist. Local caching. Local caching is available for all the major build tools on the JVM for free out of the box. Just turn it on and use it. Remote caching, free with an asterisk, because you need a caching server that will distribute the caches between the team members. And this is just an HTTP server, that's container that you can spin up, but there is some costs and time involved in that. Build scans. This goes into both observability and effective collaboration through effective tooling. BuildScan is a free tool from Gradle that allows you to monitor the build and share the information about the build with your colleagues as a link to the point of the build that failed or to the point of the test that failed. And you can win prizes for free as well, and that's coming. What your company should pay for? All the books, obviously my books, because I get royalty and your boss is paying, so it's a win-win. Top development hardware. I just gave you the case why you should get the absolute best. If you need to convince your boss to buy you the latest M4 Pro that was released yesterday or something, or will be released in the next week, whatever their presentation is happening, just show them the video. You go there, the video is there. You point them to the second when I mention from 2 minutes to 10 seconds, boom, you get a new laptop. The Velocity, that's the tool that I kind of mentioned. This is our offering for doing all the things that we mentioned, including predictive test selection and flaky test detection and a bunch of other cool stuff. And with that, if you scan it, you get to speaker.jbaruch, And there is a test, there is a thing there called the speed challenge. Speed challenge, you can take any project, your project, other people's project, and try to speed it up. If you manage, you get some awesome t-shirts. This unfortunately is not available, but we have other cool t-shirts as well. Talk about developer productivity engineering with your colleagues, with your boss, with your team. And this is the next frontier. And AI. DP handbook, handbook about developer productivity engineering. DP Summit, it's a conference that we run a couple of weeks ago in San Francisco. We're working on the videos from all our amazing speakers from Netflix and Meta and LinkedIn and Uber and Spotify and who's not. For now, the keynotes are already published, so watch the keynotes. With that, thank you very much. J Baruch everywhere. This is Devoxx, and speaking.J Baruch is where you find the video, the slides, all the links. We have 4 minutes for questions. Thank you. If you have questions, then shout them really loud and I will repeat them and probably maybe have an answer. Or we can be first in line for whatever coffee or whatever we have next. That also works. Hey.
I have some questions, but I think this is probably related to my specific use cases, so that's why I didn't shout.
Sounds good. All right, let me turn this off. Let me turn off the video and we can talk. Thank you.